introduce the conference and bit about our program and office so that we set the context again. It was done yesterday morning also. So good morning, good evening, or good afternoon in Asia. And I think it's too early. And I don't think anybody's awake in United States or Canada, that part of the world. Anyway, so we'll begin our conference. My name is Shivi Shravan. I am from United Nations Office for Outer Space Affairs. And specifically, I contribute to the program called UN Spider, United Nations Platform for Space-Based Information for Disaster Management and Emergency Response. Basically, our aim is to bring together providers of space technologies and disaster management communities. And this we do through technical advisory services that we offer to different countries to enable disaster management agencies to use space-based information in all stages of disaster management. We also conduct conferences, workshops, and we also have knowledge portal done, which is managed by our office in Bonn. So we have been active for more than almost a decade now, and we have long-term engagement with disaster management organizations in different countries to promote space technologies in disaster management. So as a part of our outreach and also bringing together the technologists and disaster managers, we organize this annual conference every year. We have organized 9 such conferences. We name it as United Nations International Conference on Space-Based Technologies for Disaster Risk Reduction. This is a series of conferences. We have hosted 9 such conferences in Beijing. You can see on screen there is a photograph. That's how it looked like before, pre-pandemic era. Now we are under COVID-19 outbreak, so this is virtual for the first time and 10th such conference. Nevertheless, we have taken good benefit of technology, and yesterday we had 2 sessions of this conference and attendance was very good and quite active. So this year we chose a theme called Lessons Learned During Unprecedented Pandemic Situation, because a lot of people wanted to know that how space technology can make difference when disasters strike during pandemic. It's a crisis within crisis. So those experiences we wanted to share. So yesterday we had already 2 sessions. The first session precisely talked about lessons learned during pandemic. A lot of disaster managers and international organizations gave their perspective that about disaster management during pandemic situation. We had another session yesterday that was more focused on space technology contribution for during such health crisis or pandemic. So more technology perspective we provided from our second session yesterday. And now today is the second and last day of the conference, and we are entering into third session. And this session is more on the, we'll focus on space for climate adaptation and disaster resilience. And it will contribute to our program called Space for Climate Action. Also, everyone has observed that during this pandemic, everyone also talked about impact of this pandemic on climate, positive, negative, both way. And you know, climate hazards, climate-related hazards are very important for disaster managers. So in this context, we have invited a very good panel for today's discussion, and requested is Dr. Komali Kantameneni from Solent University to take over as a chair and help me conduct this session. I will be still moderating this session. Mainly question and answer part, I will assist Ms. Komali on this part. But at this stage, I would like to hand over to Komali to take over as the chair and introduce the panel. Thank you. Over to you.
Thank you so much, sir. Hi, good morning, all. I'm Komali from the United Kingdom. I am chairing this session, and mainly this session focusing on space for climate adaptation and disaster resilience. In this session, we have 5 speakers. First one, Professor Engelbert Niehaus, and second one, Dr. Giriraj Amarnath, and third one, Dr. Louisa Campos, and fourth one, Miss Verena Marak, and fifth one, Marcus Oltran. First, I would like to invite Professor Engelbert Niehaus, who is working as a professor in the field of mathematics and computer science at the University of Konstanz, Landau, Germany. He is going to give a talk on link between disaster management and global health. Professor Engelbert, over to you. Could you please introduce yourself a bit more before going to the actual presentation?
Yes, I will. I will look at the disaster management and global health, and I joined since 2007 the United Nations Office of Outer Space Working Group for Space and Global Health, currently chaired by Switzerland. And we will look into that topic from a tailored spatial risk and resource management part. Please, next slide. So I'm a mathematician and computer scientist by training, but don't be afraid, I don't will go into mathematical details or computer science details. We will look on a bit on mobile computing as addressing the end users. My training in mathematics will help us a bit on spatial decision support and representing risk and resources. And the working group of space and global health is a bit similar to UN Spider. UN Spider links the space community with the disaster management.
I'm sorry to disturb. Emma, can you please make this presentation full screen? Please continue. Sorry, Bert. Yeah, please continue.
Thank you, Emma. And I added also audio slides for web presentation. So these slides with audio comments, and you see the URL below, which will be also available at the end of this session. So next slide, please. So as mentioned before, we look at the intersection between space technology, global health, and disaster management. And at this intersection, we look on spatial decision support system. Next slide, please. We start at UN Spider Regional Support Office because it's a very important infrastructure to provide member state support in the UN context, besides the advisory missions to special events, so that there is even decision support to member states that don't have satellites in orbit and have benefits for humanitarian purpose or disaster management relief. The second part, we will swap a bit to spatial decision support, as mentioned before, and look on global health and on disaster management, and derive parts of data structure and digital signature to provide trusted information to the end user. Next slide, please. So once on the one hand, we have the space assets, the technology-driven part, digital signature, blockchain to have trusted interaction. And on the other side, we have the health domain with privacy issue, data protection, and a legal framework, because the health domain should keep privacy for the health-related data. And we must provide space assets into the health domain in a trusted way so that the decision support system can benefit from both areas and provide valuable information to risk mitigation teams in the health domain, for example, vector control units, or the hospitals or public health agencies as decision makers. Next slide, please. So we looked at from an angle of One Health. So One Health is a notion for combining environmental health, animal health, and public health. The major objective is to mitigate the risk and reduce the number of people exposed to the One Health risk. With the link to the disaster management, we have natural and man-made disasters that have an impact on environmental health and on public health. Next slide, please. So when we talked about impact and having impact on the ground, and citizens should perceive that there is a benefit for themselves and have a better resilience on risk epidemiological risks, disaster management risks, pollutants risk. Then we look on the bridge from space to the One Health's impact. And in this talk, we look a little bit on the missing links. And the bridge is only viable if these links are filled with meaningful components that are operational, trusted, and reach the end user as or risk-exposed communities. Please, next slide. So space technology has three main pillars in that context of global health. So the Earth observation, satellite navigation with routing and tracing resources, ambulances, and vehicles that the mobile clinics or so forth. We have communication and telemedicine, lab on a chip as a spin-off from human spaceflight, ambient assisted living that are environments to support global health infrastructure with satellite technology. I will focus a bit on Earth observation just to highlight the links between space, disaster management, and global health. Next slide, please. Now we look on remote sensing and air pollution. So we combine remote sensing and ground data, measuring pollutants on the ground at different stations, provide decision support to citizens, and we must distinguish between urban and rural areas. Even if we have satellite images available, the impact locally is dependent on vegetation, on buildings that keep the pollutants more stagnant in an urban area, for example, than in a rural area. We must address the population density, and then the ground data is very important to have a local risk assessment. The next step is how does the public health agencies benefit from the data? They trigger risk mitigation activities, and the One Health risk in that context are respiratory diseases. The public health agency are decision makers, and they trigger self-protection, close window, wear mask, stop driving, or stop the emission of unnecessary additional pollutants. And we also can address long-term risk mitigation. So if we have major wind directions and major pollutants that affect highly densely populated areas, then we have high priority areas to address risk mitigation and reduce the pollutants so that a large number of population is no longer heavily affected, maybe reduce that a bit. That are prevention measures that are derived from space and ground data together, and have long-term risk mitigation available. Next slide, please. Now we look on the disaster management. There are similar concepts where space technology and ground response are combined. So remote sensing and ground data are combined to have to support firefighting and evacuation. And with major wind direction, we can look a bit into the future and have risk mitigation strategies planning for that. We have One Health risk according to fire and air. We have disaster emergency management agencies that provide that, and we have One Health risk to wildlife, loss of forest, loss of agriculture, and loss of assets in general that are affected by bushfires. And the long-term change, we have the similar thing that we have long-term risk mitigation to climate change for forest management or protection of cities, so that increasing numbers of bushfires have less impact on the communities in the future. Next slide, please. So going from land to water, so we look on red algae bloom, and we look also on the interface between space technology and public health response. So red tide is a harmful algae bloom caused by Karenia brevis, needs major nutrition source to develop. It appears in coastal region, and wind and current aggregates the algae to toxic patches. The One Health risk are respiratory irritation from the airborne toxins. We have skin irritation if it's exposed, that makes shellfish poisonous and kills fish and dolphins. And then we see the One Health risk, and it has an impact on fishery because they cannot sell sell their fish, and it has an impact into the food chain to protect citizens from there. So going this bridge from space technology to responses in the public health domain of food security is a bit similar pathway and has to be supported. Next slide, please. So if we look on the algae example, we have the remote sensing part, and we have on the other side the mobile devices, as mentioned in the beginning. The decision support must be delivered to local mobile devices, and it has to be in a lean and operational data structure that can be also processed offline on mobile devices. And GeoJSON is one option which can be used on mobile devices, and even the decision support can be processed on the mobile device without a backend and shared between mobile devices, even in disaster cases. A link is provided below to see what spatial decision support layers are in detail. Next slide, please. The big benefit of having these decision support layers, even on mobile devices offline, is that we can logically combine maybe humidity and temperature together to identify the risk. And with logical combination, we can identify high priority intervention areas to have long-term risk mitigation or preventive or proactive, trigger proactive actions. And the spatial fuzzy layers are condensed in a way that they're delivered in small tiles and digitally signed in a trusted way to the mobile devices, that even the users can check if this information is unchanged and delivered from the space agency or public health agency. Next slide, please. So how do the mobile devices evaluate these risk layers? There might be a small tile visualized above to the GIS layer for the risk, and the global satellite navigation system on the mobile device evaluates with the geolocation on the mobile device the risk layer and provides the risk back to the location. This can be combined with decision support infrastructure, raising awareness for a certain risk, provide access to resources that are close to the geolocation of the user. And this provides tailored decision support for risk and resources according to the location of the mobile device user. And the validation of the data structure is really crucial. The digital signature with the public key, we can check if the information is really truly delivered from an agency, and this trust in the decision support products is really essential, that users can rely on that. Next slide, please. So now we looked on the delivering of information, and we have also one layer that is related to crowdsourcing. So when people go around, look around into environment and are on the sea and spot patches of algae or see dead birds for hypopathogenic avian influenza, they can report it to a community memory. And you can, of course, understand that from the community memory directly, the public health agency will not issue a warning. They do some validation of the risk, and then we are in the red area of the public health authority, and they validate that indicators for risk. And then they issue a public warning or public awareness for the mobile device. And even if the mobile device doesn't have sensors for epidemiological risk for radiation, this mechanism of using the GPS sensor tailored to the information can provide tailored information to the geolocation of the user. Next slide, please. So now, when we summarize that, we have seen from the space domain, the space agency, space observation, global satellite navigation, and the digital signal is crucial for trust in digital support, of course. And mobile device can be used to have tailored information, dependent if it's our citizens, they have different information, or vector control units in the health domain have also different information because they have there's a different target group, but the mechanism of provided tailored information to the geolocation of the user is similar. And we mentioned the digital signature as valuable, and the decision makers are on the international level, WHO, public health agencies, or local health agencies that support regional governmental activities. In the current pandemic, the risk literacy of citizens is very important. As long as we don't have a vaccination, the risk literacy and capacity building is there. Oh, there was one question. Okay, the workflow and integration is necessary, but we discussed just until the mobile devices, and for ethical reasons, we must also address the last mile and address vulnerable people that don't have access to mobile devices. And that is, I think, an ethical point that we have to assure in that bridge from space agencies, health agencies to the vulnerable communities. Next slide, please. So, next slide, please. Okay, what we addressed so far is risk and response, and in that cycle, from the space and the health, we addressed a bit of GeoJSON for the data products. We addressed a bit of digital signature, and I mentioned also blockchain. The difference between a blockchain is that and digital signature is that an agency submits data. It's open, everyone can read it, but a digital signature is attached to that information. If somebody changed even 1 byte of that information, the digital signature is not valid anymore. That is the purpose of the digital signature. The blockchain process is that we have a network of actors that assure that the transactions processed in the network are not compromisable. And that was I think I don't have too much time to elaborate much more on blockchain and the IT properties of blockchain. So that was, I hope, the next slide and last slide, I guess. Next slide, please. So in that whole management of the system, I want to close the loop back to the UN SPIDER Regional Support Office. The space assets have to be integrated in the disaster management global health community. Especially the health community is very aware on data protection and privacy. So exporting data from the health domain to the space domain will not be a viable way. The only way that can be feasible to protect the privacy, especially of relevant health-related data, is to integrate space technology into the health domain and provide it with digital signature in special decision support systems. The whole process can be guided by the regional support office because it is an asset that is already available, and it doesn't make sense to reproduce this infrastructure for the health domain as well. I think it makes more sense to strengthen the existing strategies provided by United Nations and to operate also health support or global health support through this regional support office, if that is feasible, and the local decision makers decide that as a relevant step forward. So last slide. So thanks a lot for the opportunity to present here at this conference, and I also have this slide available for further use. You can download the zip and use it locally. And now I give back to the chair for Mari. Thank you.
Thank you, Professor Engelbert. You have delivered an excellent and outstanding presentation, and you clearly mentioned about space technology and sensing data, how they are using in the global health and disaster risk. And also, I am very much impressed with that, how the remote sensing data is using in the identification of a harmful algae bloom in red tide in coastal areas. I have a question I will ask at the end of the session. Thank you so much.
Thank you.
Now, I would like to invite second speaker, Dr. Giriraj Amarnath, who is working as a senior researcher and research group leader at the International Water Management Institute, Sri Lanka. So he is going to give a talk on climate-related disasters and index-based risk transfer. Dr. Amarnath, over to you. Before going to the actual presentation, could you please give a bit more information about you? Over to you, Amarnath. Thank you.
Giriraj.
Thank you, Chair, only for the nice introduction. And first of all, yeah, please.
I just want to tell you that Emma has received your email and she has to download. She has to download your presentation. It will take a couple of minutes. So meanwhile, you can introduce yourself. Then she will share the slides.
Thank you so much. So, changes. So, Giriraj, leader for water at International Water Management Institute. We are a member of CJR, looking after the research program on water management and sustainable livelihoods in both Asia and Africa. This is also the headquarters of Sri Lanka, IWMI, and we have presence in over 15 countries, and we do research program over 60 countries when it comes to water, food, and agriculture. And we would also like to congratulate UNSPIDER, UNOOSA for this amazing initiative, despite being a COVID with the travel restriction for hosting this event online with UNDRR. And with this, the topic was given to me to present on climate disasters and index insurance. While the presentation is to be viewed, I would just highlight the research program, what we do. It's a cross-cutting program. Given DRR itself is a cross-cutting program across sectors, whether it is water, agriculture, and disciplines related to rural areas, how risk management can be a major area of focus when it comes to resilience development, or when it comes to resilience from the infrastructure perspective, or providing communities to build resilience in the strategical perspective of development goals. And again, I think this is a greater convergence when we talk about DRR from the Sendai framework perspective, where we have a wide range of priorities. We are looking at covering 38 indicators, and IWMI is looking after multiple priorities when it comes to understanding risk, governance, and also the role of financial resilience. So this particular presentation look after broader areas of priorities in Sendai framework. And of course, when it comes to countries positioning the sustainable development goals, it also highlights how countries are meeting the responsibilities of looking at disaster risk reduction measures. So the presentation, what we were aiming to address today is understanding the scale of disasters from geospatial perspective. The previous speaker really highlighted the role of geospatial data from the human health perspective, the use of geospatial information. And again, my presentation will look more from the climate disaster perspective and looking after the solutions that the communities are able to adapt and building the resilience from the overall risk management perspective. I'm not sure whether it's possible to see the presentation. Otherwise, I also have the opportunity to share my screen if Emma can provide access to share my screen from here, if it is a possibility.
So, Giriraj, there was little trouble. She did not receive your 15 megabyte PowerPoint. I have sent her again, and I also created PPT of your presentation. So she will have it now, and I hope she can display. Emma, what's the status?
We can also send the PDF.
Can I share
PDF of the same?
Yeah, I have PDF. I can only share PDF because currently I cannot download PPT.
Okay, I sent you PDF of the new PowerPoint, which is from my email box. It's a 2 point some megabyte. It's easy.
Okay.
Yeah, please display that.
Even I don't mind showing the previous PDF also. It covers the same except a slide. Yeah. Either way is fine. Yeah, so while still the presentation is going to come, the changes I was primarily making is about the ongoing cyclone happening in India now. It's about a storm cyclone called Nivar. It's just started to happening at a wind speed of over 130 to 145 kilometer per hour, and it's mostly in the region of southern India. So for this presentation, I thought of highlighting through an animation. Nevertheless, if that slide is not possible, we can go back to the older PPT as well, or a PDF.
Is Emma, are you able to share the screen now?
I will share the old PDF only.
Okay, okay, please.
That's fine. Yeah, thank you. Yes, I could see that. Thanks again. My apology for the delay. Can we go on to the next slide? So as a starting point in most DRR presentation with the extent of disasters and the economic, this particular slide highlights the protection gap between the events versus the calamity. Largely, if we talk about the y-axis, explains the number of disasters event that are reported over the last 30 years. And what you can see is the two colors. One is the dark blue, another is the light blue. Both points out to the protection gap. So when we say protection gap is blue or the insured losses, and when it say insured losses means whether it's an industry or a community, whether it's infrastructure, any form of insurance that has happened, they will be able to recover those losses. And the light blue colors are the uninsured losses. This is quite normal in case of developing countries or the vulnerable countries, where the disasters are pertinent and increasing rate of disasters, where you can see there is a significant gap between the uninsured and the insured losses. So when it comes to risk management, when it comes to financial inclusion, we can significantly see that a lot more work need to be done. And as a statistics on the right side, you see there are roughly about 400 plus disasters reported just for the year of 2019, which points out roughly about 200 plus billion economic losses, direct losses. We are still not accounting the indirect losses as well when it comes to infrastructure losses. And again, roughly about 11,000 people have been died from this 2009 event. And a lot of chunk of these events happened in both developed and developing countries like Japan, and also to part of India, Pakistan, and Sri Lanka. These are all reporting to the large scale natural events that are happening. And these events really explains to the new normal, because you don't really see a event 300 plus in any part of years, at least in the recent 4 or 5 years. And what it really brings out to organizations like IMI and disaster management is, how are we going to look at the deficit gap between the protection gaps, which we are just discussing here. And when we talk about sustainable development goals and the framework of Sendai framework, how are we going to really look at the financial resilience component within the broader framework of risk management? And I think we also need to really understand when it comes to success of SDG, it's all about fundamentally looking after the role of disaster risk management. If we have failed to provide protection gap to meet in the next 15 years, I don't think that the SDG 2030 is achieved progressively to the outcomes what we are reporting. So we need to ensure that these silos are better connected. It's not about disaster management working silos, or the sectors who are providing infrastructure, irrigation development, or empowering the local communities, but not taking care of the fundamental principles of managing and reducing the losses of life. So can we go to the next slide? While we quantify these losses, what we are also clearly seeing is a slide here. I just want to bring to an observation to all participants. This was a super cyclone that hit countries in both India and Bangladesh. And I'm just highlighting here, we are in a much better position today compared to 10 years before or 15 years before, when cyclones were unable to be predicted by computer models. When we talk about computer models, it can be atmospheric models. You could predict well in advance. So here is a map that was prepared by IMI that has multiple geospatial information. The previous speaker also spoken about integration of geospatial information. Here I'm presenting the population map, which is showing areas where the high exposure of flood events or a cyclone. And you can also see the trajectory track in which how the cyclone is progressing to a location and what and when it's going to have the landfall in a particular location. Today we can pinpoint exactly which villages are going to be impacted by cyclone and what time and which date it's going to happen. So this is very crucial information for field response agencies or the organizations or the international agencies like Red Cross to really provide relief agencies to provide timely inputs, whether it's access to quality water or medicine or moving them to the flood shelters. So you can see here we are talking about geospatial data, shapefile, atmospheric model, background information of even you could overlay your COVID cases where it is reporting this time. So this was a peak COVID time in India and as well as in Bangladesh. So this map was very useful for policymakers, not just from IMI perspective, but also other users have been preparing this. And the good point is that it was highlighted by the agencies that roughly about 40 million people will be affected. This is a very good case study. We can say how geospatial can be useful for building resilience among communities in the region. And I think I was just referring about the cyclone, the ongoing event happening in Tamil Nadu, the southern part of India, where we can even track exactly at what minutes this event is going to landfall. So that's a beauty of integration of this geospatial with the big data systems, what we are talking about. The next slide. So I think essentially when I say in the previous slide, the quite a length of data is available for cyclone to be alerted. It can be for typhoon. You can see a huge number of events reported, not just from southern India, but also for ongoing events that's happening in 3 days before in Philippines and Vietnam. But the other form of data what I'm going to speak about is for the insurance industries to identify and manage the risk and design an index insurance, what we call also a parametric insurance. So I think for any form of risk to understand, data is very fundamentally important. And when we speak of developing countries or the countries where there is a really need of such product to be developed, we really need a credible data to design index product. And the reason is that often this is not happening in those regions because there is access to quality data is not there. So poor insurance penetration in Asia. And also we are understanding there is a protection gap is there, but it needs really a policy orientation. Otherwise the scaling and adoption of this product will be a challenge. And I think one of the bridging gap is the Earth observation data. So I would go with a few more examples of how Earth observation has been used by countries in transferring the risk from the climate insurance perspective. And I think it is also quite a good opportunity of public-private partnership here. It's not just about the government roles alone, but it also brings into weather data providers like weather station developers or the insurance company or the microfinancing companies who could all collaborate and generate a viable insurance product in the regions where we are piloting. The next slide. As an example, for people who are not familiar about what is parametric insurance, it is about any form of weather or a climate related information. Like I think any countries today, monitor the weather condition, whether it's a rainfall, wind speed, or a temperature. You could also calculate the wave height from the sea level rise. There is also an interesting launch a few days before from European Space Agency and NASA on the Sentinel-6. It's going to monitor the sea level rise from this new satellite data. It's basically a communication satellite. And you could design a data. What is fundamentally important is you need a historical data to understand the losses that are happened back in time, so that you know what is the premium that can be set, what can be the losses that are captured, so that insurance companies can prepare credible policies that is a win-win and transparent as well. It's not just preparing one product using a short period of duration. That is one, and it's a predetermined threshold in the sense, understanding the historical data, you set a trigger value. Let's say a rainfall more than 200 millimeter, anything that goes with the specific day, or communities living in urban cities would be able to compensate it. And then it should be tailored to the user demand. It's not just a supply side. The product has to be made to the local need. So when it comes to flood insurance, I will be presenting in my next slide. It's all a participatory approach to design this product. Can we go on to the next slide? So it's a very simplified version I'm presenting here, but you are free to visit more details from our websites. So index-based flood insurance is basically a combination of computer models and earth observation data. Here in an example where we design a product at a village level, the models are able to predict the likely areas of inundation. And the center image is a Sentinel-1, shows the extent of inundation. You can see a good correlation between the model-based and the earth observation, which is very important for during the time of claim settlement, where the trust of using this data lies with such modeling information, and as well as the snapshot taken by the Copernicus Sentinel-1 images. So we have tested this over 7,000 households, both in India and Bangladesh, and we provided a payout, not IWMI, the insurance company, over $150,000, and we are integrating this into the wider program of resilience before, during, and after disaster, so that this integrated framework can be used from the perspective of pre-disaster, during crisis, and after disaster, how this framework can be used. And IMI has recently won the Geo SDG award for the innovation from the group of Earth observation. Sometime last month, this recognition was provided to us. The next slide. So this is, again, I would now move on to the example case study. This was in fact a ceremonial event happened yesterday with the government of Bangladesh, where the union minister was there briefing and providing the digital ceremony in Bangladesh. You can see here the beauty of the partnership and alliances are highlighted here. You can see the colorful logos. Each one has their own significant contribution here, whether it is Oxfam, World Food Program, Green Delta. They are all the mobilizers of making sure that distribution partners like MFI adopt this solution. So we have tested that in northern Bihar, and you can see the data is provided by IWMI when it comes to developing design and providing the claim settlement. We have provided 5.4 million Bangladesh currency to the eligible farmers. That's about 2,000 households we have tested. And during the time of COVID, it's again an opportunity how digital services can be empowered. Here it's a bKash, is a mobile financial service company provided directly farmers or the communities directly in their mobile account, which is very popular in Bangladesh when it comes to access to finance through the mobile system. So this is a testimonial of our solution, how this is being used by the end user. The next slide. Moving from a flood aspect, I just want to also touch upon the drought. Equally, both it's when you twist a coin, you have both side of the problems. In the climate side, both floods and drought. Here is a simplified version of slide. Again, you are free to visit our website to learn more about our drought monitoring system. As an example, I'm showing here is South Asia. We have a knowledge products and we can take credible, actionable information on monitoring to management. Here we are designating the information to extension where they could use this information for response strategies on drought. So we are educating the farmers how these informations are useful from climate information service perspective, and how the local authorities can predetermine those management decisions to be activated. We want to keep this management decision on a book rule, but also digitally enabled. So we are using big data, the remote sensing data, the field information, the policy guidelines, all were put together, and also the weather station information, so that the local officials could able to make timely decision on how the surveillance systems can be made, not just for the monitoring purpose, but also looking after from the management aspect. In fact, this again recognized by the global agency, the geospatial industry has given this award for the system what we developed. So again, I'm free to reach out to you to provide more information on this particular product. The next slide. Yeah, so I just want to also bring to the bigger picture of the problems of managing floods and drought. Here is an global information of data provided by the World Resource Institute, where they are prepared a global models on knowing where the flood is happening with the different return periods on both floods and drought. We integrated that with decision support rules to come up with the overall water risk. Again, this is the data coming from WRI. And what you see on the right side is the crop production information. So what the main element I'm trying to present here is, when the institutions develop quite a significant data on risk information and also the production losses, you have an opportunity to integrate this and provide the next version of product, like how do we connect water stress information with the crop production in order to understand the impact of food security, not just today, but also look after the products over the next 20 to 30 years. So this particular product, what I'm showing here, is how this risk is going to look at in the next 20 years of product. So once you have this integration between water risk and production data, you can come with how countries should manage to the risk management aspect, look after the sustainable development targets, whether it is hunger communities or providing water scarcity issues, like you have different SDG goals. You could look at how countries are going to look at. Again, this particular product is not just for single crop. We have built this information for 40 major crops around the world. So again, this is when it comes to global climate adaptation, these products are going to be the future set of information where you could manage those extreme risks. And I think this might be my last slide. Can I look at the next slide? Yeah. So thanks again to UNOOSA and UN Spider for giving this opportunity. And also I thank my partners who are supporting this initiative. And over to you, Kumali, for giving this opportunity. Thank you.
Thank you so much, Giriraj. It is an excellent presentation. You clearly gave the information on how the technology are using to accurate predict of the cyclones in these days, and also mentioned about parametric insurance and index-based flood insurance, which I like very much, and other things as well. Thank you so much. Now, I would like to invite the third speaker, Dr. Louisa Campos, who is working as an associate professor and co-director of the Center for Urban Sustainability and Resilience, University College of London, simply called as UCL in the United Kingdom. So she is going to give a talk on space tools to assist water and sanitation management in disaster and emergency management. So over to Louisa. Could you please give a bit more information about yourself before going to start the actual presentation? Thank you.
Thank you, Komali. Good morning, good afternoon, and good evening, depending where you are. It is a pleasure to participate as a speaker at the annual UN Spider Conference. Thank you for inviting me. My name is Dr. Louisa Campos, and I am an associate professor in environmental engineering at the Department of Civil, Environmental and Geomatic Engineering of University College London. Next slide, please. In my presentation today, I will start with a focus on disaster risk management cycle. Then I will focus on potential applications of space technologies for water and sanitation services in disaster risk management. I will also talk briefly about a project I am co-lead, looking at digital innovations to manage floods and droughts and their associated disease. I will end my presentation with some final considerations. Next slide, please. The disaster risk management cycle includes preparedness, response, recovery, and mitigation. Spatial tools, such as satellites and drones, have been used to support these 4 phases of the disaster risk management. These tools can be used to support the prediction of disasters, hazard mapping, early warning system, monitoring, and helping search and rescue operations. When there is a disaster, water and sanitation systems are potentially affected. For example, wastewater treatment plants, latrines, and septic tanks can be flooded during flood events, spreading fecal matter in the environment. Water dams and reservoirs can dry completely during droughts or be damaged during earthquakes. As a result, affected communities will not have access to clean water and sanitation facilities, increasing the risk of disease outbreaks. Without safe and clean water, people are at high risk of disease, such as diarrhea, typhoid, and cholera, and also increasing vulnerability to malnutrition. Therefore, if spatial tools can assist water and sanitation management during preparedness, response, recovery, and mitigation of disaster events, disease outbreak can be mitigated and potentially avoided. Next slide, please. Next slide, thank you. Here, I introduce some applications of drones and satellites. Sorry, previous one. Is the previous one, please? Before. Yes, that one, thank you. Here, I introduce some applications of drones and satellites in water service and provision, highlighting that these tools have limitations during extreme weather events. After a disaster event, drones can help to locate water boreholes, hand pumps that are operational or damaged. Drones can deliver spare parts to repair water pumps and pipes. If there is a need of installing portable drinking water tanks, drones can help to quickly identify areas where this can be located. In addition to visible imagery, thermal infrared satellite observations can help to identify surface and groundwater source and monitoring water quality and quantity. For example, hydrologists have used information from gray satellites to calculate terrestrial water and groundwater storage. It can also help to support allocation of water from a reservoir that provides hydroelectricity, drinking water, and agricultural irrigation. This type of support is very helpful for preparedness and mitigation actions before a drought event. Next slide, please. One example for using space tools in water quality is monitoring of blue-green algae growth in water reservoirs and oceans. Egilberto mentioned about the importance of monitoring algae bloom in water bodies, so I don't need to say much here. But I just would like to say that because drinking water can be taken from reservoirs, monitoring of blue-green algae in water bodies, it's important. There was an intoxication case that caused human deaths in Brazil in 1996. Next slide, please. Other useful application of spatial tools is for sanitation and wastewater infrastructure monitoring. Drones are already being used by some sanitation providers to inspect wastewater treatment plants. For example, drones can be used in unsafe locations like the interior of sewers and pumping stations. Drones can be utilized after a disaster event to identify excreta disposal facilities that are operational or damaged, and to help identifying existing sewer systems that can serve as temporary latrines. They can be used to identify wastewater treatment plants that have been flooded, that action is taken before fecal contamination is spread in the environment. If there is a need for relocating people from one area to another, drones can be used to identify locations for portable wastewater treatment plants and toilets. Drones can be used to identify illegal discharges in areas subject to floods so that preparedness and mitigation measures are planned. They can also deliver packed latrines, bucket latrines to communities in areas where sanitation facilities have been destroyed. Next, please. Next slide, please. Here on the left, we see a drone used for distribution of medicines in emergency. To accommodate temperature-sensitive drugs, Softbox adapts a robust insulated packing system. So I see a great potential of drones delivering, for example, people bags, which are biodegradable plastic bags, bucket toilets, and hygiene products such as soap, which are vitally important for disease control. I highlight here that the selection of toilet requires understanding of the local context, including cultural aspects. Next slide, please. Other application of drones is for stormwater drainage system monitoring to support preparedness and mitigation strategies. These two photos from left and right show common situations found in areas of low and middle income countries subject to floods. The middle photo shows a car found crammed in a drainage canal of New Orleans in 2019 after a flood event. Apparently, they used an underwater drone in this canal. So the use of drones to identify potential blockages before or after flood events can be very useful. Finally, in the case of relocation of people, drone and satellite data can be used to provide topographical surveys to support the design of stormwater drainage and sewage systems, wastewater treatment plants, drinking water treatment plants of campsites. Next slide, please. Now, I would like to briefly talk about the Overcome project in which I lead the intervention working package. Overcome is led by Exeter University. The project is funded by GCRF Digital Innovation for Development in Africa initiative. The aim of Overcome is to establish a transnational consortium with multidisciplinary expertise for cross-sectoral collaborative research in creating innovative technological methodologies and applications to manage droughts and floods and their associated disease. Our collaborating African countries are Malawi, Mozambique, Zimbabwe, and Ghana. We have secured a 12-month fund to run network and capacity building activities. This is helping us to build an interdisciplinary team and define a methodology for a follow-up research in the second phase. The aim of the second phase is to deliver an ultimate holistic framework that supports stakeholders from a wide range of sectors in strategic planning and decision-making to enhance societal resilience to climate hazards. So space tools are of our great interest, and we welcome collaborations. Next slide, please. Here you can have a quick look in our project partners. Next slides, please. Finally, I would like to conclude that the use of space tools to manage water and sanitation provisions in disaster risk management helps to reduce disease outbreaks by providing wash services and preventing contaminations. So the use of satellite and drones observations can improve predictions, risk assessment, and early warning systems. However, there are some challenges. One is technology costs. GPS signal may not be strong enough to support drone flights. Internet in some areas is not reliable. The integration of indigenous knowledge with space tools is very important, as indigenous technologies are usually developed with reference to local people's culture and environment. Other issue is the expertise, which may not be available, particularly in case of drones, as they may require a qualified pilot. Also, there is a need for a regulatory framework for drone operation, particularly if it is to support preparedness and mitigation measures of disasters, which does not classify as emergency. Finally, there is a need to enhance coordination and communication between the key actors to make sure each sector not only acts efficiently when required, but also has access to the data. Next slide, please. Thank you very much for listening.
Thank you so much, Luisa, for an excellent presentation. You gave your valuable information on space technology for water infrastructure, and also explained very well on drones and satellites, how they are using in the provision of water and sanitation. And also you shared the information about the Overcome project. Thank you so much.
Thank you.
Now, I would like to invite fourth speaker, Ms. Verena Marak, who is associated with the Regional Academy on the United Nations by courtesy and also the University of Vienna, Austria. She is going to give a talk on opportunities and challenges in the use of space-based technologies for flood management in urban Africa. Over to you, Verena. Could you please give a bit more information about yourself before going to the actual presentation? Thank you.
Thank you very much, Komali. Just like to say that it's the wrong slides.
Emma, it's the wrong slide. That's
No
for
worries.
Marcus. Yeah, maybe you can introduce meanwhile yourself.
Yes, my name is Verena Marak. I'm together with a transdisciplinary research team with Elisabeth Bergler and Victor Hertel doing a qualitative research on space-based technologies and flood management on behalf of the Regional Academy on the United Nations, which gives young academics the opportunity to conduct research on aspects that the UN is especially interested currently. And I was lucky enough to do that research on behalf of the Regional Academy and in cooperation with UNOOSA. So a warm hello and good morning and good afternoon and good evening from my side. To start my presentation, I would like to ask you a question. Where's the link between those two images? I would encourage us to find the connection and use it for the benefit of all. Next slide, please. So I have already introduced myself. So we did a quantitative research on the usage of this technology for flood management in urban Africa. Our research was conducted on behalf of the Regional Academy under United Nations and in cooperation with the United Nations Office for Outer Space Affairs. I would like to send a short disclaimer ahead. The results I'm presenting today are preliminary, since our research has not been published yet and should be seen as a snapshot of the current situation with no claim to full comprehensiveness. Next slide, please. Thank you, Emma. 5 topics on the agenda today: research method, the current situation in flooding in Africa, benefits of space-based technologies, and challenges split in the what, the who, and the how, and where our interview partners spotted potential solutions. Next slide, please. So how did we conduct our research? We conducted 9 expert interviews with 3 different types of institutions: UN organizations such as the UNOOSA and UNESCO, governmental organizations such as the National Disaster Management Organization in Ghana, and representatives of the private sector and academia such as Planet Labs and University of Salzburg. Next slide, please. Let me shortly outline the current situation. We are facing the mega trend of urbanization, and I want to highlight 3 aspects in that area. A, according to UN Habitat, the urban areas in Africa are among the fastest growing in the world. B, there is an overpopulation of coastal areas, as you can see on the map on the right of the Sahel West African region. And C, there is an increased risk of flooding due to climate change, rapid urbanization, and land use change. The socioeconomic impacts also, as we have heard today, of flooding are huge. According to the report, Togo alone lost $10.4 million every day due to erosion, flooding, and pollution. So information to prevent these incidences are often too late, not enough, or not at all. Next slide, please. Next slide, please. Yes. How can space-based technology improve the situation? There are a number of initiatives that are assisting in that process. The UN Spider, of course, as a bridge between the space community and the national disaster management organizations. And there are emergency mapping mechanisms such as the International Charter, Space and Major Disasters, and the EU Copernicus Emergency Management Service, and Sentinel Asia. Why are all these initiatives promoting space-based technologies for mitigating climate change risks? In the following slides, I'm going to talk about the benefits of space-based technologies, challenges, and potential solutions. Next slide, please. Let's start with the benefits. We all know that high-quality data is absolutely key to make good decisions, and space-based technology offers that. Instead of sending out vast amounts of people to conduct surveys that need to be reported back and compiled together and put into a final report, space-based technologies offer accurate and near real-time data, even from regions in Africa you would not normally be able to access at all. Furthermore, it offers large data of large areas, which is especially relevant for flood management. And finally, of course, you can survey the whole Earth, regardless of national borders. So you know exactly when your neighboring country is opening that river dam, whose water will cause severe flooding in your country, like it's sometimes in the case with transnational rivers in Nigeria and Ghana. So to conclude, space-based data always has a much better idea. However, there are also some challenges to overcome. Next slide, please. There is the challenge of what? What kind of data can I access? To do effective flood management, high quality data is key. Publicly available data, for example, the freely accessible data from Copernicus program, does not offer high enough resolution to do useful flood elevation models for local case studies. The private sector does, of course, offer high quality data, but that isn't for free. Third of all, it is critical that data is compatible and combinable with other data to bring together all the relevant information that you need for your daily work. Next slide, please. If you can access the right data, there's the question of who can handle it. As one of our interview partners said, you can't just throw data out there, technology out there and expect people to use it. For example, first-line responders might not be trained in reading and using flood maps. Project managers might be experts in the project strategy, but they do not understand the basic technology behind it. So misunderstandings, like you can see in the image on the right side, might happen. Another problem arises in the sustainability of projects. Sometimes technicians come from the so-called developed world to a developing country in Africa to conduct the project. For the duration of the project, the technician is there and is doing his project. But as soon as the project is ending, he is going back to his or her country and no knowledge is being transferred. So this is still happening. Also, satellite imagery is especially useful if local knowledge is applied, because the local understanding is key to leverage the information on the image. Next slide, please. On the challenge of how, on the same note of sustainable projects, what I call low-hanging fruit projects are implemented to generate outputs to justify funding. But instead of projects building up on each other, there's a new project implemented to generate output to justify funding. So there's a lacking sustainability and interoperability in the context of project development. Another point is lacking funds. There are great ideas and great projects landing in desk drawers of emergency management agencies that are not being implemented because of lacking funds. There's the case of lacking bandwidth and access to data. Lastly, as one of our interview partners said, it's a very complicated field. So space-based technology has the image that it's very nerdy, very techy, and not everybody can handle it. So it should be designed as user-friendly as possible to leverage its full potential. Next slide, please. So how to overcome all these challenges? As a side note, these recommendations have been derived from our interview partners and are not comprehensive. I will present 4 of them. More needs to be done in the field of awareness raising and training on different levels, government, private sector, and the general public, on what can be done with space-based technology. Secondly, capacity building. Access to data, as well as the trend towards cloud computing, should be enhanced. With cloud computing, lacking bandwidth is not an issue, not a big issue anymore, and technical resources are not needed anymore for processing the data. Also, data communication should be improved. There's a gap to bridge between the tech world and the project managers and the policymakers out there. Better communication is key to gap those issues. Also, the application of space-based data should be as Apple-like as possible, as one of our interview partners said. Training of first-line responders in using flood maps, informing project managers of the basic and technological background would increase understanding and communication. Also, I would encourage us to move away from a reactive stance to a more proactive stance. Focus on preventive measures should increase. For flood management, this means access to high-resolution digital elevation models, hydrological modeling, and risk assessment. These shall inform building codes that are being also enforced. Hydrometeorological observation activities should be improved, as flood and drought are one of the major disasters happening in Africa due to climate change. Lastly, climate change cannot be solved by one institution alone. It needs to be addressed through fruitful cooperation. Different stakeholders need to be sitting on a table to come up with new operation possibilities and new solutions. Especially the private sector might be an actor that hasn't been included much yet, like insurance companies and reinsurance companies. But it's important to note that partnership and cooperation should be self-sufficient and innovative and creative, like you can see on the picture on the right side. To conclude, the technology is out there and it has been proven to be relevant to mitigate negative effects of urban flooding in Africa. It's time to streamline and mainstream the applications of space-based data in our everyday working environment so that we can always make the better and hopeful, as Mr. Talbot discussed yesterday, the more ethical decision. Last slide, please. I hope that the link between those images is even more traceable now. Space-based technologies enables us to address urban floods in Africa faster and more accurately. Let us use it ethically for the benefit of all. Please feel free to get in touch for comments and feedback in the chat box or via email. And I would now thank you all and hand it back to Komali.
Thank you so much, Verena, for your very interesting presentation. You clearly mentioned about the mega trends of urbanization in Africa and also overpopulation trends in the coastal areas, and also mentioned how the space-based technology improves the life. And finally, you mentioned also the data challenges. Thank you so much. Now, I would like to invite our last speaker and fifth speaker, Marcus Walton, who is working at the United Nations Office for Outer Space Affairs, Vienna, Australia. He is going to give a talk on space for climate action. Over to you, Marcus. Could you please introduce yourself a bit more before going to the actual presentation? Thank you.
Thank you very much, Komali. I hope you can all hear me and already see my first slide. My name is Marcus Walton. I'm working in the Office of the Director in the Office for Outer Space Affairs. I'm in charge of different activities. As such, I'm also involved in the so-called Space for Climate Action initiative of the Office for Outer Space Affairs, which was just initiated recently. I'm going to give you a bit of a different presentation compared to the ones which we have just heard. I'm going more in the policy side and how we can pull all these great initiatives which you have heard just right now all together and advance collaboratively. So next slide, please. So we have started putting together a Space for Climate Action portfolio with last year's summit in New York on climate action, which was hosted by the Secretary General. Obviously, the topic on space and climate action has been active in the office since years, but given the starting point from last year at the Climate Action Summit, we went back to the drawing table and started to put together a new outline, or is it really new? And that's something which I would like to discuss in the coming slides. We have heard in this session already applications and tools and how we can address climate change from different activities, and I think it's all common knowledge now that we are in a complex climate crisis, and we know that this has effects on different areas and parts of our living and of our being on Earth, and we must mobilize every effort to mitigate and adapt to these realities and consequences of the changing climate. So just to stress and underline the last point, since it's perfectly fitting here, that between 1989 and 2017, natural disasters killed over 1.3 million people and insured more than 4.4 billion. We know that due to different studies that the changing effects on the climate has a potential increase on disasters globally, and that's something which is not only addressed within this session, but that's something which we are trying to address within the Office for Outer Space Affairs. Next slide, please. So we know from the climate science that there is over 50% of the 45 essential climate change variables can be monitored from space. So we know that space technology is essential already from the climate science perspective. We know that colleagues in other UN agencies and other UN departments are using space technology to prove that climate change is a reality on the one hand side, but also that the effects of climate the climate change has an effect on our living. We have heard studies on the impact of or the usage of space technology for flood management in Africa, and we have also heard other presentations. So that's already a reality, and we from the United Nations and from the Office for Outer Space Affairs since last year, since the call for action, are more going into the area of what kind of activities can be made. So the data gives a more precise understanding, obviously, of the climate change and its drivers, which is critical for policymakers and for decision makers. And what we have been assessing that space technologies, while we obviously see here in this conference that space technology is used to address climate change and climate impacts, it is still underused globally. And it can be used in different efforts, and we have heard a few examples already before that. So just to stress and underline, space technology can be used for mitigation and as well as adaptation and resilience. Next slide, please. So what is our role as the Office for Outer Space Affairs? So I said in the beginning that I will be trying to underline and stress a bit the role what the UN Office for Outer Space Affairs is doing. So to summarize, we can come up with three different elements. On the one hand side, obviously the office is a capacity builder, providing access to space data and information, and building capacity on the usage and the applicability of space space technology. The Office for Outer Space Affairs is a convener, so facilitating international cooperation among member states, and it's a gateway. So it's not only an access point for UN agencies to use satellite technology for the different challenges which we have, but also for member states and external stakeholders. So as the Office for the Space Affairs, we are responsible for advancing the use of advancing international cooperation, the peaceful use of outer space. And we have the mandate to develop and implement a program to support sustainable development, including climate action. And as I said before, it was on the agenda since years, and we are just moving now more in the direction of the climate action action front. So next slide, please. So I'm unfortunately, I didn't have time to see the presentations which Shirish gave yesterday in the morning to set the tone and set everything what you are trying to accomplish within this conference. I just wanted to give you an overview of the various capacity building initiatives of the office. And as such, I have included the Space for Climate Action as a new initiative. So you can see the work of the office reaches from regional activities for space solution in the Pacific to the very broad thematic access to space for all activities. You all know UN Spider, obviously, to have thematic narrowed down activities on space for women, for example, or space for water. So this is just an overview of the various activities which we are focusing in the office to address the various challenges underpinning the SDGs. Next slide, please. So what I have tried to underline and what I have tried to carve out is that full potential of space technology in addressing climate change is currently not being realized. And we are trying to come up with a bit of a research in the analysis of how we as UNOOSA can see our role in the future. And UNOOSA has identified areas in which it can help enable global climate action by using space assets. So overall, the Space for Climate Action Initiative aims to promote strengthening and delivering targeted capacity building, technical advisory, facilitate multi-stakeholder collaboration, and promote efforts to encourage the use of space climate action from local, national, and international levels. Next slide, please. We all know that SDG 13 is the one which is addressing climate relevant actions and climate activities, and that's where the Space for Climate Action Initiative is targeted for. And the first step for our internal assessment of what we can do is was trying to understand the gaps. What are the gaps where is a niche for UNOOSA? We didn't want to go ahead with a duplication of efforts of other UN agencies. We didn't want to go ahead with duplication of activities which are done in space agencies already. So we wanted to come up with a real activity which is filling the gaps. So we have analyzed 30 different initiatives across national space agencies, governmental organizations, academic organizations, and we have studied national and regional capacities. We have looked at other UN organizations, and we have also looked on the link to the so-called Space Climate Observatory, which is an initiative from the French Space Agency, which is also trying to build up capacities in the use of space technology on a national level. So next slide, please. So in our assessment, we came to the conclusion that although collective and global nature of climate change requires a strong component of global response, so meaning that there's a joint effort, we also see that recent policy analysis advocates strongly for a top-down and a bottom-up approach for climate action. And that's where we have identified the niche for UNOOSA. So while we see that top-down measures, international cooperation to achieve the global picture of climate change is necessary, there's also a need to foster and to promote the capacity building among bottom-up measures. So effective actions in agriculture, resource management, manufacturing at regional and global levels, at local levels, taking into account unique societal context and immediate benefits to the communities there. So what we have assessed and what's the current state of research is that there's obviously a need to come up with and follow UNFCCC's and the Paris Agreement, the requirements there. There's also a need to foster stronger collaboration on a national and bottom-up approach. Next slide, please. So in summary, the Space for Climate Action would look into space data, so looking at availability data that enables a robust scientific understanding of the climate change's effect and its drivers. So that's a layer which is already very well addressed in various areas in the world. Capacity building and advisory, so evidence-based policies and decision-making that allow national and regional government to work towards reducing greenhouse gas emissions, plus international initiatives and bringing the various initiatives together. We can take it as an example, obviously, under SDG 17, which is Partnership for the Goals, which also includes private sector initiatives. So all of this combined would formulate the Space for Climate Action variable. Next slide, please. And how does it look? How does this look in the plan of action? And I have to underline here that this is, as the status as we have seen it today, is a research and a paper exercise. And what we are trying to do in the future is to reach out to interested stakeholders, partners, counterparts who are interested in putting this Space for Climate Action into reality. So it would be the use of Space for Climate Action as a first step in the promotion of the use of space technology for climate. Next slide, please. So awareness raising, outreach, which leads, yes, that one, thank you. So next, this one, awareness raising and outreach obviously leads to the need to capacity building, facilitate training, facilitate capacity building, design, monitoring, and evaluation of implementation projects. So really be on the ground and support interested stakeholders with the capacity building, which leads to the next step. Next slide also. To the need for coordinating these international efforts. So collaborating between the UN organizations on the one hand side, but as well government agencies, academic organizations, and then to help and implement national and regional climate adaptation and mitigation projects. Next slide, please. I already mentioned it, and that's one of those initiatives which is currently very strongly driven forward by our colleagues and counterparts at the French Space Agency, CNES. We will be trying to support from a from institutional framework building setting, the support of the Space Climate Observatory. It will be a gateway to space-based information and tools to support climate adaptation and mitigation projects on a national level. And UNOOSA will try to support the setup and the next step as to our best efforts. To all who are interested at the moment, there is an opening call for a labeling exercise of space for climate action relevant projects under the Space Climate Observatory. So I'm happy to type in afterwards the link to the Space Climate Observatory in the chat box. So if you're interested to submit project proposals, which you think could be fitting under this Space Climate Observatory, please feel free to reach out to me, and I will be happy to guide you through the next steps. Next slide, please. And then we move into technical assistance and cooperation. So what here is obviously a mechanism that we have seen successfully implemented by UN SPIDER, and we have a broad expertise in this area already built up, including technical advisor missions and institutional strengthening missions. What is potentially a new element here is that we would be trying to support stakeholders and interested countries when it comes to the application for international calls, that we build in space technology from the beginning onwards. So space applications are already a core element in the reply to international calls, such as the Green Climate Fund, for example. So there might be a relevant activity or action to address climate change in a country, or initiated by a stakeholder, and we would be helping those countries to see what role space can play already in the design phase of the project. So that would be an additional element which we are trying to achieve with the Space for Climate Action initiative. Next slide, please. And then we all know and we have heard that there's a strong call for a private sector participation. The Office for Outer Space Affairs, through our committee, we have received the mandate that we can include the private sector for addressing the global challenges, and there will be an effort from the office to include the private sector as much as possible in all our activities. Next slide, please. Yes, and that's I guess most of what I have presented sounds very common and sounds very not very new to you. Some elements might be a bit newer, but some elements might be already taken from existing successful initiatives, and that's why I am happy that I was able to speak to you today on Space for Climate Action, because the link, obvious link to the setup and programming of UN SPIDER is there. Obviously, it needs a bit of different approach, but we would be using a successful existing initiative as UN SPIDER as a pattern which we will be trying to follow, from actually lifting it off from the ground to the implementation domain. Next slide, please. So just in a summary, I just wanted to give you a bit of a summary slide of what I have presented today. UNOOSA to support, or the plan of action to support Space for Climate Action, will be serving as a secretariat today to support the Space Climate Observatory, being a gateway to space-based information and tools, coordinate collaboration between governments, develop and implement national and regional climate adaptation and mitigation projects, providing technical support and analysis, facilitate capacity building, and provide the use and awareness raising of best practices to use space technology to meet climate objectives. Next slide, please. So where are we at the moment? What's the current status? And that's my last slide already. What is the current status? Where are we at the moment? As I said, it's currently a bit of a paper exercise, but we are looking for partners. So we are supporting the steering committee of the Space Climate Observatory. We are doing outreach and awareness raising. We are in bilateral discussion with partners. We are already supported through a staff member who helps us to lift this off the ground. We are building the business case and the business plan. We are setting the framework and the parameters, and we are establishing the structure of the process. So we are actually we have designed in the business plan a phased approach. So we are in phase 1, but what we are looking now and what we are trying to achieve from now onwards is actually to generate interest among international stakeholders, which help us to move not only for the implementation of phase 1, but also going then directly into phase 2 to consolidate the program and follow the lead of our colleagues at UNSPIDA to establish a really globally well-known and well-respected program, which is one of the important stakeholders. While SPIDA is it for disaster management, we would aim for the Space for Climate Action in a similar role within the climate action front. So thank you very much. Last slide, please. Thank you very much for your attention, and feel free to reach out to me if you do have any questions. Stay tuned for updates. Thank you very much. Kamali, over to you.
Yeah. Thank you so much, Max, for a very interesting presentation. You gave very valuable information on how space technology enables the climate action and also how to reduce the emissions and pollution. You also mentioned on capacity building and also mentioned evaluation of landscape of climate initiatives. And finally, you gave the information, very valuable information on plan of action. Thank you so much.
Thank you very much.
And now we have finished all speakers' presentations. Now we have a question and answer section. Sirish sir, could you please help me to take over the questions, please?
Sure.
Oh, thank you so much.
Okay,
sir.
I will.
Yeah, thank you.
So thank you, Kamali, for nicely sharing this, and thank you all the panelists for wonderful contribution and sharing their experiences. I'm seeing some of the questions in the chat box, but let me read out what our panelist Verena says. Okay, so some questions panelists tried to address already, but who are here, I will try to take advantage of their presence. Unfortunately, Giriraj has left because he had another meeting, and there was a question from Mr. Karthik to Giriraj on about how one can trigger a value or threshold for parametric insurance work, and he already addressed that question in the chat window with the so I think that he has taken care and he has left. I also see there is a question from one of the question to Mr. Engebert about blockchain. He had tried to address when he was presenting, making his presentation towards the end. But Bert, if you are still there, would you like to elaborate on how and where blockchain can be applied? Would you like to contribute a little more on that?
Yes, there's a difference between blockchain and digital signature in the way of application. I will go into the details of the cryptographic mathematical details, but I will look at the application. Assume a data provider, a data product provider issues a product that be uptaken by communities for decision support products. And they provide this information into information channels. The digital signature is the appropriate measures. Even people at the end, the consumers of the product, which are integrated and have fused data, the end user should be able to validate, yes, this information was from that provider. It can be applied also from official information from WHO, so that are not altered in the process of information processing. If we think about blockchain is distributed. If we think about distributed organizations that work autonomously together, then they contribute to that blockchain, and any alteration is assured mutually by the other information without having a centralized organization. So we have that problems in projects. So maybe the ESA cannot monitor UNOOSA or something like that. So they are independent organizations that work together, and any alteration is added to the blockchain, and nobody else can change that alteration without corrupting the validity of the data product. So that is I hope that helps a little bit to distinguish between digital signature and blockchain. Thank you.
I think that's great. Thank you, Bert. And see, your presentation was little uniquely placed in this particular session, because yesterday we had a session dedicated for health, and today more on climate, and yours was kind of transition linking all these elements. And I think thank you for your contribution on this.
Sir, I have a question to the Professor Engelbert.
Yes, please.
Professor, I really impressed how the remote sensing and spatial technology are using in the identification of a harmful algae bloom, that is red tides in coastal areas. Could you please give a little bit more information about that?
So in a summer school at our university, in collaboration with El Salvador, we joined the group of Space and Global Health. They had this algae bloom in coastal regions in Central America, and they worked on the remote sensing detection, and also worked on ground specific data. And there was also one question in the chat that I want to also address. What is the contribution of remote sensing? So they have ground data for measuring pollutants on the ground, and going upstairs we have the wind system, and the wind system, the basic use of the wind system is to use it as a transport process and use the ground system to validate which are the pollutants that are on the ground. If you want to look at noise tube is a thing that with a mobile device you can detect the exposure to noise in urban areas. And this is a really good approach to use the mobile device to have the local sensors, because the smartphone is there where the users are. And so it's a good measurement for the ground data to have the exposure of the people, because that are the endpoints of risk. And the same can be to integrate the public observation into the process, because it's not only for collecting data, but because it's also valuable for raising awareness for the problem. Thank you very much.
Thank you so much, Professor.
Good. Thank you. And then there was one comment by, Mr. Fei Assurance. It is said that GIS and remote sensing programs are very expensive, and it's also a drawback in using the technology. Probably I will ask Verena to comment on that. Is it because what I want to say that if you go to UN Spider Knowledge Portal, we have complete section on all open source data that is available from remote sensing satellites, and also open source tools which can be made use of. A lot of recommended practices showing approaches how you can use those free tools. But probably, Verena, would you like to address this particular comment?
So maybe I pick it up. So thank you very much, Sirius, for addressing open source and open data. So decision makers, if we look on open source environments, for example, Shiny Web Apps, the Shiny Web Apps with the dashboards are the front end for decision makers to visualize the process. And the R and R Studio are very free available tools from the processing side, and they can handle spatial data. On the other hand, what is really lacking on the side of the integration, to have the application programming interface, to have it uniquely harmonized between the health domain and the space domain and disaster management, to make it really interoperable. So I think there is a lot of work also done in the disaster management communities, but also we have to link it to so that we just have, for example, the Geo app Linux distribution, set it up, and all the interfaces are already implemented, and share this Linux distribution without commercial obstacles for participants to integrate that into the decision support system. Thank you very much.
Thank you for this. Someone speaking. Okay. There was one question regarding, is there a web portal to identify risk areas? Else, how mobile device identify risk locations? I think this is quite a general question. Anyone in panel would like to address this? I think mobile device something. Luisa, you were talking about some mobile devices. Unfortunately, Giriraj is not here. He could address that.
So I can explain a little bit the technology. So excuse me for talking too much.
No, please welcome, because if other panelists are not coming in right now, maybe you can talk.
So if we have it on a mobile device and reporting things, I mentioned GeoJSON as a format. Also, the report things can be submitted to a RESTful API. That is one key element. It doesn't have. It just have a back end that receives the data from mobile devices. And also the application is a web application that is can be delivered by web interface, and an app LSEC can run it locally on the system. And Open Data Kit is one tool that is used by Red Cross and so forth to have offline data collection and submit it to submit the collected data when it's online. It can record the geolocation where the data is collected and get by this mean a joint repository for using this. So Open Data Kit is one option to go further. So excuse me, I don't want to take too much time.
Good, and I just wanted to add that for risk areas identification, there are lots of web portals, and some very well known are developed in cooperation with United Nations Office for Disaster Risk Reduction, and they are called Disinventar or Damage and Loss Assessment kind of portals. They are available, but more can be found on UN Spider Knowledge Portal also. Then I see there is a question by Mr. Rajendra Agarwal on, can we see live pictures of cyclone Niwar through UN Spider? So this is the cyclone. So let me take this question. This cyclone it has hit already Tamil Nadu state in India. So I just want to clarify that UN Spider will not really relay any live pictures of any disaster, but we will support monitoring of such disasters through the space-based application. And essentially, we have mechanisms, and some of the mechanisms were shown through presentation of some of the panelists. I think mainly Verena showed. The names are like International Charter, Space and Major Disaster, Sentinel Asia, Copernicus Emergency Management Systems. So these are some of the mechanisms we activate based on the request from the member countries. If there is a disaster and they say, okay, we want to monitor this particular disaster using satellite images, then we activate those mechanisms, and satellite images of pre and post disasters are provided. But in the case of India, Indian Space Research Organization itself is the member of such mechanisms, so we don't need to come into picture. India can handle this, and if not enough, definitely we are there to help. So that was my comment on that. And okay, so I think mostly the questions which were put by the participants are done. I just wanted to comment also on something very important, where I mentioned that when we are applying space technologies, specifically she talked about a lot of things in Africa. I think loss of expertise is more common. We train some people or we build capacity and people go away. And I think UN Spider is mainly contributing into keeping long-term relations with the institutions to establish coordination, keep the capacity. And that also was highlighted by Marcus. And I just wanted to mention in that context also that Space for Climate Action, he said a lot following the example of UN Spider. And at this stage, I just wanted to say that UN Spider, why United Nations and other technical providers of space technology, they should connect, is because we have got very strong connect with the countries, with the people who are in driving seat to save the lives with the disaster management. And these people keep changing. And UN Spider being part of United Nations, we are continuously in touch in the countries with those persons or those officials. So after 2-3 years, we see officials have gone to another department, but we are still in touch with the office, and new persons who come on board, we try to offer our technical advisory or outreach programs so that they are aware. And that is the reason why this particular conference is offering a very good platform of how the technology solution providers, they can through UNOOSA or UN Spider program, keep in touch with those who wants to use that. So this bridging is basically done by our program very, very well. And I think this conference serves this kind of purpose. I have no more questions. So what I can do at this stage is maybe...
I have a question, sorry. I have a question to Louisa, Dr. Louisa.
Yes, Komali.
Yeah, Louisa, I have a question. Your presentation is very interesting. The drone data, actually, when we are using the drones, it is economically not visible to the normal people. And at the same time, there is a lot of process to take a permission. How did you manage? Could you please share your experience?
Yeah. On my presentation, I explore the application of drones and satellites is quite, it's well established in areas of preventing disasters and also predicting disasters. But in terms of the water and sanitation, there are still a lack there, right? Not much has been done there. So with my presentation here today, I just wanted to highlight that there is a gap here that we do need to perhaps explore and explore the potential of these tools to benefit, those that in particular, because as I highlighted, water and sanitation services are very important when comes a disaster, because of the disease outbreak. So in terms of you ask me how they are using, they have been using these tools in the US, in Europe. This is a well established. But when it comes to developing countries, it's not a established technology that can be used easily. So there are a lack of the first thing. That it was a question in relation to the costs. Right. And when it comes to the cost of an integration of drones and satellite data that are very important, require also other programs that low-income countries, they may not have those programs on hand when it's necessary. And the integration of those programs require also training capacity. And then when it comes, we do internet connection. So this is a challenge that the sector is facing. How could we have access to all, right, of these brilliant tools that are satellites and drones, and for the good of all, So, but I think that we are still a step back of the universal application of the tool, as Verena presented on her slides.
Thank you so much, Louisa. Thank you. And I have a final question to Verena. Verena, are you there? Verena?
No, we don't get any response from her, probably.
Yeah, it's okay, sir.
There in the list, but maybe she's busy somewhere. Yeah. Okay.
It's okay, sir. It's okay.
We can interact. We have email ID of everyone.
Yeah. Yes,
and I was thinking we have 5 minutes. So any panelists would like to give any last message before we close this, before we give it back to chair? Marcus, do you have anything to comment?
No, Sirish, just to remind us, look like there are 2 questions on the QA there that they haven't been, we haven't talked. One is the space technology and drone technology. What are needed to integrate both for climate action? And the other is does UN Spider have disaster register platform? If it does, yes, that's for you.
Would you like to reply those?
Myself? No, for the cost, I do agree with the person who made we do need to have integration of both. But I myself, I'm not an expert in the space tool itself. I'm an expert in water and sanitation. So I prefer someone that has this knowledge here, right, that can reply to that question. How to integrate both climate for climate action. I don't know if Marcus, perhaps Marcus was talking about climate action.
These questions with the when I was something else. So,
yeah.
Marcus, do you have any reply?
Well, I have to admit I'm not a technical person as well. I'm more on the policy front, and I'm more the one who's trying to coordinate and put it together. So it's great that you have been targeting me with the question and put me on the spot. And I would love to give you an answer that would mean that we have advanced on the climate action portfolio already, and maybe we'll get there in the future. But I have to, before I go into the wrong direction, I have to admit I'm not the most suitable person to answer this question.
Okay. Then I see a question from Yao. Does UNSPIDER have disaster register platform? Do you mean registering all the disasters? If so, you're asking that, it's not that. There's another system called EMDAT that registers all the disasters, and also every country has their registration. We only address the supporting space-based information for disaster management. And I think someone tried to reply also. There's from Mr. Prakash Cho, and mostat.gov.in has the rapid cyclone images. So someone asked, can UNSPIDER provide live images? And there's reply already by Prakash Chavan, who is a panelist in the next session. So Marcus, you want to say something?
Yes, please. Before we close, and I think that's really a relevant point, what Louisa mentioned before. On the one hand side, the capacity building, and what you said, that we are trying to replicate what UNSPIDER is doing. I think that's why events like these are really, really important, that we can work together and do it in building the capacity. And I think one important element, what Louisa mentioned, is that we have not the capacity globally that everybody can access the data. And I think I just wanted to highlight this is another area of the UN which we are trying to achieve through another initiative at the UN. So there's the Global Connectivity Initiative, which was done and started by the Secretary General already over a year ago. And there's one recommendation, which is recommendation 1A, and they are trying. There is an effort to global affordable access to the internet by 2030. Obviously, that's a high-pitched goal by 2030, but there are satellite data providers, there are ground station operators, and there is a network of stakeholders trying to address this objective by 2030. And obviously, and that's something which I wanted to highlight, obviously one of the sub-recommendations in recommendation 1A is the need to integrate the disaster management communication within that domain. I wanted to highlight that while we are yet to come to the space where everybody has access to data and has the feasibility, the technical feasibility to download and access to the internet, there is efforts within the UN to overcome this effort, to overcome this gap. And I think that's something which has to be highlighted as well. So thanks a lot, and thanks a lot for this discussion and the presentation. I learned really a lot. Thank you very much.
Thank you, Marcus. There's one question. I don't know if we can really address this. The question is it possible to use robots with space technology in disaster risk recovery? Bert, would you like to say something, or who can address?
Sir, can I address this question, sir?
Yes,
Actually,
please. Yes,
I am not. In 2018, I have attended one of the disaster management conference in Andhra Pradesh, which was held in Vizag. Some remote areas, they are using a small size robots, which the human beings are not able to go to there, because some areas are very dangerous to enter the human beings. But some people are still living there. To give the information, they are sending these type of robots, very small robots. So that have the knowledge I have, and after that, I don't have any information. So.
Yeah, but I would just say now, as World Economic Forum says, the world is now heading to industrial revolution technologies, wherein information technology, robotics, and blockchain technology, everything will combine together. I think this is quite a forward-looking topic, and we should really consider this. So thanks for this thought-provoking question. I think that we are already 11 o'clock, 2 minutes more than what we should be. So we can conclude. Thank you everyone for participating. Thank you, Chair. So last remark or closing remark from you so that we can stop this session.
Yes, sir. First of all, actually, I am greatly honored to chairing the world renowned scientists and this conference. Thank you for the opportunity, Sri sir, and really enjoyed all the speakers' presentations. They are very brilliant and innovative. Definitely, I learned very interesting things. Thank you so much. So I will contact in the future to collaborate and for other things like journal articles and collaborative projects if you are interested. Thank you so much and enjoy the day.
Thank you for sharing, and thank you, Emma, for displaying slides from China. So within 1 hour, we have another session. Hope to see most of you back again in that session. So bye now. Thank you, everyone. Thank you all.
Thank you so much. Thank you for having me. Bye. Thank you.
Thank you.
Bye. Thank you, Verena.
Thank you. Bye.
Bye. Thank you, Gail, for hosting us.